Units, Dimension and Error Analysis, Chapter 1. In this chapter, we'll discuss about units and dimensions of different physical quantities and error that occur in the measurements. Okay, so first one is physical quantities. Here, there is physical quantities. All the quantities which are used to describe the laws of physics are called as the physical quantities. Okay, example: length, mass, volume, etc. Okay, to express the measurement of physical quantities, we need to know two things as below. Okay, the unit in which the quantity is measured, numerical value or the magnitude of the quantity, that is number of times the unit is contained in a given physical quantity, is nu. So here n is inversely proportional to 1 by u. Okay, which is nu, which is equal to constant. Okay, here numerical value of the physical quantity u, which is equal to size of the unit. So we may write as n1 u1 is equal to n2 u2. U is the size of the unit. So we can write n1 u1, which is equal to n2 u2. Okay, here n1 n2 are values of physical quantities in two different units, u1 and u2. Okay, number 1, units. The standard amount of physical quantity chosen to measure the physical quantity of same kind is called as the physical unit. Okay, in that we have system of units, that is a complete set of unit which is used to measure all kinds of fundamental and derived quantities called a system of units. Okay, some of the commonly used system of units are as follows. Number 1 is cgs system. Okay, in the system the unit of length, mass and time are centimeter, gram and seconds respectively. Okay, here the unit of force is Dian. Okay, and that of work is erg. Okay, a unit of force is Dyne, unit of work and energy is erg. Next number, second system of unit is fps system. In the system the unit of length, mass and time are foot, pound and seconds respectively. Okay, here the unit of force in this system is poundal. Okay, next one, third system is mk system. Okay, in the system unit of length, mass and time are meter, kilogram and second respectively. Okay, here the force is Newton, N, capital N, and that of work or energy is joule, that is J. Okay, now let us solve some of these questions regarding to this system of units. Okay, okay. Here, the acceleration due to gravity is 9.8 meter per second square. Give its value in fts square. That is that fts square. We have to give the value. Okay. So solution is, as 1 meter is, that is given value, that is we have as 1 meter is 3.28 ft. Okay, here we have answer as 1 meter, that is 1 meter which is equal to 3.28 ft. So therefore, 9.8 meter per second square, which is equal to 9.8 into 3.28 ft per second square. So, multiplying this one, we will be getting 332.14 ft second square per second square. Okay, we can approximately write as 32 feet. Okay. We are using the significant figures, that is the reason we are getting 32, we are taking approximate values. Okay, next example. Oh, next is some other units. So okay, this is some other units for we have to remember them. Okay, 1 micron which is equal to, this is the symbol which is equal to 10 to the power minus 6 meter. Number 2, 1 nanometer which is equal to 1 nm which is equal to 10 to the power minus 9 m. Okay, third one, 1 angstrom which is equal to, and that is a simple, which 10 to the power minus 10 meter, 10 equal to 10 to the power minus 8 centimeter, equal to 10 to the power minus 4 meter. Okay, number 4 is 1 Fermi, that is 1 Fm, which is equal to 10 to the power minus 15 m. Okay, number 5, 1 astronomical unit, that is 1 AU, okay, which is equal to 1.496 into 10 to the power 11 m. Okay, next sixth one is 1 light year, which is equal to 9.467 into 10 to the power 15 m. Next, number seventh one, next one is 1 parasec. Okay, here it is equal to 3.08 into 10 to the power 16 m, which is equal to 3.26 ly. Okay, which is equal to 206267 AU. Okay, these are some other units, not contained in SI unit, okay, of this regarding the length. Okay, next is a questions regarding to this one. Okay, how many microns are there in 1 light year? So we should know the value, what is 1 light year. Okay, here 1 light year means that is 9.46 10 to the power 15 m, which we studied in some other unit that is not contained in SI unit. We studied that 1 light year which is equal to 9.46 and 10 to the power 15. So here 1 meter which is equal 10 to the power 6 micron. Okay, so 1 light year which is equal to 9.46 into 10 to the power 15 into, that is 10 to the power 6 micron. Okay, by solving this, we will be getting 9.46 10 to the power 21. Okay, 1 micron. So approximately by taking the value, we will be getting 10 to the power 22 microns. Okay, this is the approx value. Next question is, how many microseconds are there in 10 minutes? Okay, so here same of that, 1 second which is equal to 10 to the power 6 microsecond. We know the value of the micron, that is 10 to the power 6. So here 1 second which is equal to 10 to the power 6 microsecond. So in 10 minutes, we will be having 10 into 60. We are converting it into seconds. Then we have to multiply it with the microsecond value. So we have 10 into 60 into 10 to the power 6. So by multiplying this, we will be getting 6 into 10 to the power 8 microsecond. So this is our answer. Okay, thank you for watching my video.